So actually today is a great day for me as I have finally completed the algorithm my own algorithm which I was working for artificial intelligence. After I saw the movie of Iron Man, I just wanted to make the Jarvis which was just over there. So I was just figuring out a neural net model. So now I actually have my own neural net model and programmed it in the computer. So actually in the Java programming language, it took me around 4 weeks. So now the algorithm is completely ready, the neural net model is completely ready. Yeah, just the performance issue is there because it's still a prototype, right? So it's still a prototype, and yeah, I hope so. I'll just fix the performance issues over there. Yeah, due to which I am using I think it's a not 16 by 80 minutes. Before I was using the 16 by 80 minutes. Now I think I am using the somewhere around. I think it's like 50 or by 40 images, I think so. Yeah, okay, so here are the images. So I think it's like 60 by 40 or 60 by 25 something, I think so. So it's actually the dimension of the image I'm using. So you might be wondering that why I'm using such a low means resolution image. So that's actually because high resolution image contains more pixel, and processing that means tons of pixel would take forever, as I've already tried to do that. And yeah, and it's really take forever means it will just keep on processing, and after half an hour it will just give you the result. So that's basically means useless for testing purposes. So for testing purposes I use these small images, and the algorithm which I made is for kind of spatial recognition. That is, we can use it for image recognition, speech recognition, and it's more kind of like a bioneuron means how a biological neuron behaves. And I just try to means made it behave in such a way so that it would behave like a biological neuron means how a biological neuron behave. And after seeing the so there no one's there. So after seeing this video, after I think around a year or two, I would just think that yeah, I have made something before a year or two. So you might have seen my before videos. That was I think so yeah, it was of the God's Eye, which was again I saw in the movie of Fast and Furious. That was around 4 years ago. So I just programmed it, and after this is this is the work I've started for the Jarvis or the Ultron, which was just right over there. So a mixture of both kind of two, which you say that it's okay. So it has been already 2 minutes, so I won't be wasting a lot of time, but it's not gonna be like Ultron Vision means it's gonna be something else like a kind of iRobot movie. So I'm still working on this. So actually the neural net model is completed, and I would implement it on speech recognition means I don't want to do it for speech recognition. I want to make a complete model of human brain, which is actually over there in means computer. And I don't want to use any pre-existing model which is like already CNN and perceptron, multi-layer perceptron. As means if these layer would be so efficient, means these models would be so efficient, someone would have already made a human brain in the computer, but we still are not. Means the model which we are currently working on is it's sufficient. Means I don't know why. Means when I work on these models, means when I just study about these models, when I come to know about these models, I just think that no, it's not kind of like how means how naturally human neuron behaves, and not a human neuron means biological neuron. Because biological neuron behaves just simply means it just adds the current, it averages the current, it multiplies the current. We just means wanna figure it out that what a neuron does. Either it averages the current, multiplies the current, subtracts the current. Means actually it's more kind of common sense than a kind of science and technology. So still we need to figure it out. So let's see the testing. Okay, so I think I should switch to back camera. Okay, so there's no switching button in my phone. Yeah, so you might be seeing this. Okay, so I means I'm just switching off the video, and I'll be switching to OBS Studio. After this you will be seeing it over there. Yeah, so now here we start our OBS recording, and now I'm gonna show you the neural net model. So here's the main class of the neural net which I just made over here, and this is the test image which I'm gonna test. So okay, let's bring you to the directory. So actually the main directory is over here, text storage, Pointers, AI. Oh yeah, and here's my other program which I just made earlier video. and over is AI. And currently, like we are in phase 11. Means phase 10 has been completed, and it was like in phase 11 I just made some new advancement and some new updates. And phase 11 I have just copied it to the documents folder in the C drive because there was some problem running the Windows PowerShell. So I'm like, okay, first let me close it. So I'm like just using the CMD menu over here. So let me cut it over here, and then here's our main file. Okay, and here's our match.jpg. Means this file we are gonna match with the other database, and we are gonna check out the percentage that it's across or not. So here are some of the training database which I just created over here. These are the training images. Okay, here's another, and means it can just detect the noise and just remove it. So like in this image means there's a rectangle and there's a cross, so the program will understand that it has to not take the rectangle and it has to take the cross actually. So like this it will just means detect the common features in all the images and then match to these images. And I just tried that the program should behave like a real biological neuron and a real human brain. So let's go to the command prompt window and then cd. We are gonna change our directory to this right over here. Yeah. Okay, so one minute, please let me close the door. Yeah, actually I was getting some sound from the door, so I just closed it. And now when we have, okay, so now we just change our directory. So here's our, let me show you the main.java file over here. So here's the these are some of the threshold values. This is a 55, means there are total 55 images out here, and just ignore this line. Okay, this line is kind of like useless. Means that's why I just kept it as a comment. Means before I was using this line, but now I'm not gonna use this line. And these are like for checking the means neural net that it's working correctly or not. And I've just already tested it. And over here is the match.jpg, means the new image file which we are gonna just match. That's right over here. This one match.jpg. Okay, I was actually pointing it by my finger, so you cannot see my finger actually, or you can, I think so. So here's 55. Let me repeat it. 55. That's the total number of images. Match.jpg. Here the matcher function, which is in the PS1. That's the PS1 is the picture asset, right? Match.jpg. That's the image which we are gonna match. So let's get started. So first we're like, why not again compile our main.java. Okay, come on, yeah. So now we are gonna run our program, Java main. Okay, let's minimize it for a time. Okay, so our program is run and there's like a kind of 78% match. Means our program thinks that this image is 78% across. So why not to means test it in each and every way. First, why do like let's scale the image. Means first let's make this this smaller, and now Java main. Okay, I have not yet tested it like this, so let's see what the result is gonna be. Yes, okay, so it's like a 62% cross. Yeah, and now let's move it over here and then check it again. And now we are waiting for the output. Okay. So I think that it's a 49% cross. When we bring it to middle, Control plus S, Java main. Come on. Okay, so it's into 69%. Means like yet I am not able to figure out that why it's happening. Means the program which I made, like it should be able to detect everywhere. Means it's means if the cross is over here, it should detect it. It should be like 69%. If it's 69% over here, then it should be 69% over here, and everywhere. So I don't know why this is happening. So again, so our means matches were like 69%, 49%, 62%, and a 70%. So we can say that above 50%, we can say that it's a cross. So I want to erase it and let's draw a new image. I think probably this image. Control plus S, Java main. Okay, come on, give me a good result. Come on, come on. 74%. My test just failed out. Shit. So today is like the second day, and yesterday I just tested my neural net and it completely failed because like before I just tested my neural net, yeah, and it was working fine for the shape rectangle, and I just tried making a bio means biological neuron in computer, and I think my model would be wrong or something is really very bad with the network, and I think so I think these threshold values would be wrong or there would be a bug in my code because writing the whole code and then uh, I just uploaded all the codes on my Google Drive, and I think like a year or two and after a year or two when I will open my code, I think I'll find the bug and then I'll fix it, or I think I just need to reprogram my whole means program because I just programmed my means whole program once, and I just kept fixing the means bugs one after another, and I think due to that means there's an error, and like now I'm just completely fed off. Means okay, there's a message, yeah. And now I'm like completely fed off. I just don't wanna work on this neural net. Means you can see like my eyes are like I'm like working around 4 hours a day on daily on neural net, and like when there's a school, I am working like around 2 hours at night because 6 hours my school from morning 6 a.m. and then I have like my tuition from 2 p.m. and then I just come home at 8 p.m. So I just don't want to work more on this code. Means I think means I just plan making like something like Jarvis or so on, but means everything just got messed up. Means like I should have done my work properly by yeah. So I just want to like discuss means how the neural network actually works. So when I like seeing this means after this video after some time means after a year or two, I'll understand myself that yeah, like this internet was working. So actually it takes image means it compresses it, right? 4 by 4 means padding which is done in CNN. I just means I was already working on like how to make a neural net, and the only problem which I was having is converting means image or speech data into features. So actually it converts feature by padding, means I just do 4 by means 2 by 2 padding. That's actually 4 pixel. So first I just convert the image into white and black. Means you just make the borders. Means in this I am not doing okay, but actually my model should do this when it will be like colorful image. So that means I can actually draw borders like there's a human face, so there will be a border like this. Means and I have already completed that program and that works quite fine. And then it means blurs level by level. Means actually it just padding means first layer compression, then second layer, third layer, fourth layer. After it like compresses all the layer, means it just like in each and every layer there is like many mathematical values, means numerical values. So it stores all the numerical value, okay, and then it goes to the second image, and then it stores all the numerical value from that image, and it matches both, yeah, it matches both, and it finds a common thing, yeah, okay. So it finds a common which we name it as a universal feature, and this universal feature is matched with the third image in the training data set, and then fourth, fifth, sixth, seventh, and then it goes on, and like all the common features which is means just found in all the images is taken as actually universal feature. That's actually how I think the biological neuron in our means in any carbon living organism works. So by this we actually get many common features in all the images, and then when we get a test image, then we compresses it, and then after compressing means we get like many mathematical values which are actually the features, and then we match it from the existing means universal feature. So means depending on the number of matches we actually calculate the percentage that is actually match found by the universal features array length, and by this we actually found means what is the length of this. And I actually downloaded one of my backup file of this neural network and trying fixing it, but I was actually not able to fix it because that is also the same program means which I miss my whole work has been just messed up with this, and I think I'll able to fix it after a year or two, I hope so, or the next month, or when I will means when I will feel better after working on another project, I think so. So that's all for this.